Hi, welcome to IT and Automation. In this YouTube channel, we try to share our experience, learn together. My attempt here is to share around Kubernetes. And today we are going to cover scheduling decisions. One part of the scheduling decisions, we will be talking around pod disruption budget. So scheduling decision in Kubernetes is pod creation and rescheduling period where it goes through a bunch of evaluation process. From that, we will be talking into one particular scenarios or one particular factor here, which is pod disruption project. I will be walking through some of the codes and the information that I'm going to share will be always available in IT and Automation GitHub channel too. So now let's talk about pod disruption project, right? So when Kubernetes does make scheduling decision, there are lots of other factors to evaluate, but one of the stream is pod disruption project, right? And it checks the PDB. So Kubernetes in various scenarios like node recycling, scaling down, or rolling updates needs to manage the lifecycle of the pods. However, it lacks the inherent knowledge of how these actions may impact the availability of your application. So pod disruption project serves as the mechanism for users to communicate or to tell Kubernetes what is the level of disruption you're going to accept for your application. So by defining this PDB, which is a short form of pod disruption budget, user specifies the constraints around like how many number of replicas has to be alive at a given point in time or has to be in a ready state at a given point in time. So let's talk about what is PDB then, right? Kubernetes resource that helps to ensure the availability of your application. A way to tell Kubernetes what your application state should be from an availability point of view. The simplest PDB definition I could come up with. How does PDB look like from a working code perspective? So let's consider this as a deployment. Right? This is our sample Nginx deployment, which is asking for 3 set of replicas there with a match level app Nginx. That selector is going to be key for PDB when it checks for application namespace, which is default. Without a PDB, Kubernetes does not know the constraints of the pod disruption. This means that during maintenance, Kubernetes is going to terminate these pods, all of those 3 replicas. As a result, if your image pull period is longer or if your startup period is longer, you will have disruption, you will have a downtime for the amount of period it takes to come up and serve the traffic or be healthy. So without a pod disruption budget, that's the knock-on effect of disruption or the downtime that you're going to face. And how does the pod disruption budget look like? It is completely isolated resource, which this is it manifest. Very simple 9-line in this particular example, where it says this is the kind of pod disruption budget. It is not V1 beta 1, actually, it is a V1. The API version is V1. Metadata Nginx PDB, any name that you would like to give. Spec says I need at least 2 available pod for the resource that matches this selector. Right here, we are saying match level equals to app Nginx, and if you look into the deployment that we checked before, it has the metadata level app Nginx. The pods will have this level. Pod disruption budget will try to see for those levels, and it will try to always keep 2 at least. So with the PDB in place, Kubernetes will consider the constraints specified, and when scaling down, upgrading, or performance maintenance activities, Kubernetes will ensure that at least 2 pods with the label app Nginx remains available. If terminating pods would violate the constraints, Kubernetes will delay it or halt the action. What does this do? Is this helps prevent some of the situation where too many pods are disrupted at simultaneous time, and it maintains the desired level of availability, which means you basically set the constraint or you did set the acceptable disruption and Kubernetes followed that. So whether or not it is critical really depends upon the scenarios, right? If we look into these topics here, Application availability requirement. If your application has a strict availability requirement and any downtime or service disruption could have significant consequence, it is critical. But if that is not the case, you may not need PDB. Impact of pod disruption. Consider the impact of pod disruption on your application. If terminating a pod causes the data loss or transaction rollbacks, or it could be latency, then you would consider PDB. Deployment environment, risk management, and operational practices. We touched upon some of the reasons there. Anything in production can be considered critical. If something is in production environment, you would pretty much like to guarantee the availability, and PDB helps ensure that. This minimizes the risk of downtime and ensures that application continues to serve requests. Risk mitigation. By defining those explicit constraints again, you mitigate the risks. And they provide kind of safety net where too many pods are not terminated simultaneously and avoids the downtime. Compliance and SLA requirement. If you have SLA requirement, these are quite important. Operational stability. You don't want frequent maintenance, and also the cost side of things, right, can also contribute. Unnecessary scaling events, resource wastage, things like that. We talked about PDB considerations, reasons. We looked into those deployment sample and how exactly the PDB configuration looks like. But then now, not to miss upon this particular topic here, is there a situation where PDB is not being honored? So, as I mentioned in this description here, Kubernetes strives to honor pod disruption budget and maintains the application availability. But there are certainly some of those occasions where PDB may not be honored fully. If you have insufficient resources, if the cluster lacks the sufficient resources to maintain the specified number of available pods, unplanned disruption, outage on the node level, and if the pods are binned into the same node, there can be trouble. Forced eviction can also cause this in certain scenarios, such as training a node or maintenance. That could be part of it. Misconfiguration causing the problem as well. If those selectors are wrong, the selectors that we looked in this example here, if say your selector is wrong, the app name is different to the app name mentioned on the deployment here, and you think that your PDB is set, but it doesn't actually link, that could be one problem too. In rare cases, manual overrides, right? The administrator or operator may manually override PDB constraints. So overall, Kubernetes aims to adhere the PDB constraints, but there are possible scenarios where it could be not honored. So yeah, if we recap this, we looked into scheduler decision, and in one particular evaluation factor for disruption budget, if there is a PDB, if that constraint is met, it continues towards the scheduling decision. If PDB is not met, it will delay, and if it still doesn't meet, it will actually halt the scheduling process until you hit some sort of timeouts. That's pretty much it for today. Next time around, we will come with other topics around the scheduling decisions. Thank you.